All right, this video is just going to go very quickly through the transformations of functions. If we've talked about parent functions before, well then we know that all four functions on the screen right now would be x cubed functions, or basically the regular parent function of each one of these would have been y equals x to the third. What we want to realize about the transformation of functions is basic operations just move our graphs around very simply. So again, if I graphed all four of these functions up top and made a table, here are the functions down here at the bottom. What I want to remember is, again, x cubed, it would look like just an S curve. So similar to that first function over here at the left, where we're looking down here at the bottom, it would have gone through the origin, and we would have sort of S curved our way upwards and sort of downwards, going down here. So the major effect that saying x cubed plus 2 had on my function was that it shifted, notice from the blue line up to the red line, we've shifted ourselves 2 units upwards. Now, when we talk about transformation of functions, we want to be very specific. So we want to say what direction we went. Did we go horizontally or vertically? We also want to talk about what type of transformation it was, because we'll talk about other things outside of shifts as well. And in geometry, the technical name for this would have been a translation, but we're going to use the simple idea of, we're just going to call it a shift. All of the points on the blue line shifted up 2 units, or basically our original graph. We just added 2 to each of the y values, right, to our function after we had cubed it. So basically it changed all those y values, plus 2. Well, what about if we said minus 2? Well, notice what happens. We would have been centered at the origin, but now we're down 2 units. So very simply, subtracting 2 after we've cubed it, or outside of that cubic function, we've shifted it down 2 units. So again, direction, vertical, what type of shift it was, or type of transformation it was, a shift. And then we want to be specific. We went 2 units and we went 2 units downward. Vertical is very helpful to say, but again, up versus down is also a very big difference. Now notice here we're inside of our cubic. We're going to subtract 2 or add 2 before we cube the function, if we think about that order of operations. So notice on our graph this time, instead of traveling up or down, because it affected the x coordinate before we cubed it, we've actually shifted ourselves either to the right or to the left 2 units. Again, notice the 2 in the equation, right? The exact measurement, which were changed from that parent function, right? Of which were changed to the parent function. So we're horizontal this time. We've shifted still, because again, we still just kind of translated or slid our points. Only this time we went to the right, here we went to the left. Now you might notice up top, that seems a little bit backwards. X minus 2, in our minds often negative in the x direction, well that should go left. But notice in our function, what we're saying is we've subtracted 2 before we've cubed it. Our old points, right, from our original parent function, the points that we're going to use are exactly 2 units to the right. 2 actually causes us to find 0 cubed, what used to be 0 cubed. 10 would actually be 8 cubed, right? It would have been our old number from 8 cubed. So when we plug our numbers in, we're sort of getting numbers that used to be to the left, now they're to the right. The easy way to always remember that is if we're adding or subtracting outside of our function, after our function, it's going to travel up and down. It's going to travel just like we would think it would. But if it travels before, right, if we shift before we cube it, well, then it's sort of backwards of what we would think. Subtraction is going to take us to the right. Addition is going to take us to the left. Inside of our function always sort of operates backwards. Now that happens for multiplying as well. So when we're taking a look here, we're multiplying by 2 or we're multiplying by a half on the outside. What actually happens is we're stretching. Normally we would have been at 1, 1, right? But now I'm up here at 1, 2. Normally I would have been at, 2 cubed would have been 8 times 2 is 16. So I used to be 8, right? Would have been off my graph anyway, but it used to be 8. Now we're all the way up at 16. Basically all of my y values have been doubled. So again, this time we call it a stretch. We vertically stretched by a factor of 2. If we multiply by a half, well, the opposite's going to happen. All my numbers are half the height, or half the y value they used to be. What used to be 1, 1 now is down here at 1, 1/2. Well, that's a vertical shrink, we would call it. Again, these would have been called dilations in geometry. We're going to be very specific though. We're going to call them a stretch and a shrink. Vertically shrink by a factor of a half. Because these operations are inside, you'll notice that again, we got to think horizontally. Horizontal things happen inside of that function, okay? So if you multiply by a half, horizontally and also backwards, notice that horizontally, again, 1, 1 now became 2, 1. All right, and negative 1 now became negative 1, or negative 2, sorry, negative 1. We've moved in the x direction. We've moved horizontally, and because it's a half inside, we've actually stretched by a factor of 2. We've done the opposite of what was there. Instead of cutting the x's in half, we've actually doubled the x's without changing the y's. So it's a horizontal stretch by a factor of 2. Well, in that same case then, if we're multiplying by 2 inside of our function here, it's going to do the opposite. So again, it's horizontal because it's inside the function. It's before we've cubed it. But instead of times 2, we're actually cutting it in half. Horizontally, that looks much more narrow, right? It would have been sort of swooping outside here for my normal cubic function. We would have kind of gone outside of it. Now that red line is definitely inside, horizontally much closer to the y-axis, a horizontal shrink of a half. So again, we've talked about shifts, we've talked about shrinking and stretching, right? Shifting dealt with adding and subtracting. Shrinking and stretching dealt with multiplication. Notice the one thing we haven't talked about are negatives though. And when it comes to negatives, basically we're just going to reflect. So it kind of makes sense if a negative is outside the cubic. Again, we're reflecting that over the x-axis. If your negative number is inside, we're going to end up reflecting it over the y-axis. Again, to reflect over the x-axis is a vertical reflection. To reflect over the y-axis is going to be a horizontal reflection. So notice what happens to our graphs, right, when we take those away. Well, now they look alike. So this is where it gets a little bit tricky. What you got to remember is that negative on the outside took all of our negative values here, right, that were going downward, and it flipped them, right, vertically. We moved them vertically over that x-axis. Whereas on the other side, again, all of those numbers that are used to be, right, going here, this time they were flipped horizontally, right, this direction. Because that negative was inside my function, it's a horizontal reflection. I know graphically that's hard to tell, and on the table that's hard to tell. But we want to keep our rules kind of very consistent, if you will. Adding inside shifted us left and right. Multiplying inside was a stretch or a shrink horizontally. So therefore a negative on the inside is going to be a horizontal reflection. Everything happening outside my function, on the other hand, is going to be vertical. All right, I hope that helps you think about transformations. If you have any questions about that, make sure you talk to your teacher or possibly watch a few more videos. I'm going to make a few more videos as well that'll talk about examples of how this is going to help us graph and identify functions very quick and simple. Have a great day.